In this video, I will show the calculation of square membrane by means of hand calculation and Ansys, and then I will put results to my website. Now let's start. The formulas given here are valid if only equation 2.6 is valid. This equation shall be valid. Here, 2a is the width of the membrane. Not thickness, width or breadth of the membrane. T is the thickness, P is the uniform load applied on the membrane, and E is the elasticity modulus. Here, sorry, there is a mistake here. Let's correct my mistake. I'm waiting for the program starts. This was Turkish, it means or. Let's put more distance here. If this is equation, both of them, one or the other one holds, then you can use these two formulas to calculate the midpoint deflection, vertical deflection of the square membrane, or to calculate the midpoints tensile stress. Of course, tensile stress, no compression stress occurs in the membrane, because you cannot carry the compression stresses. You can use these two stresses. Now we have an example here. For the membrane given at the right hand side, 2A is the width of the square membrane. Again, its edges are fixed. A is 10 inch, so the width of the square membrane is 20 inch. Its thickness is 0.0001 inch, and elasticity modulus is so much, Poisson's ratio is so much, thermal expansion coefficient is so much. This is the uniformly distributed load on the membrane. Calculate membrane's midpoints vertical deflection and tensile stresses using hand calculation, and repeat the calculations using Ansys software. You checking the first equation reveals that the hand calculation formulas can be applied for the solution of this square membrane. And then the midpoint deflection and tensile stress is calculated. Here the sizes are almost same. Here the diameter was 20 each and the thickness was the same for the circular membrane. For the square membrane, one side's length is again 20 each and thickness is same, this much. If we calculate the midpoint deflection, 0.462, we see 0.556. So using a circular membrane is advantageous in comparison to using a square membrane. It makes less deflection. But in terms of stress, midpoint tensile stress, with using formula 61,000, here less. But from the standpoint, tensile stress, using a square membrane has advantage on using a circular membrane. Again, this is the algorithm used in Ansys to make the analysis. Let's explain the commands. This is the title. It's also actually not required to make the analysis. It's just shown in the window of the program. By means of this command, we enter to the modeling commands. Element type is again shell 181, and to make it act as a membrane, key point 1 is selected equals to 1. Section type 1 is user defined, 1 is user defined here. Is shell, and shell's thickness is given here. Shell's material property is material 1. The thickness of section 1 is again written here wrong. I have corrected it. Elasticity modulus of material 1 is entered, and thermal expansion coefficient and Poisson's ratio are entered to the program by means of these comments. MP means material property, EX elasticity, modulus ALPX is thermal expansion coefficient, NUXY is the Poisson's ratio. Key points are again entered to the program. One area is drawn, and then the area is meshed. A coarse, very coarse mesh is used. Let's see. Okay. Square. Working directly. Let's make this square. Run this program, not in batch mode. Now I will copy paste these commands to the program. Command line. You see 1, 2, 3, 4. These are the key points. An area is created, and all of the things in the module are selected. This is one area we have. Element type 1 and material type 1 is used when finite elements and nodes are created by means of meshing. Line element size is 4, means that this length is 20. Line element size is 4. So along one edge, 20 divided by 4, we have 5 elements. 1, 2, 3, 4, 5. You see the here hidden red lines. They means line element size. Now let's create our coarse mesh. Yes, this is our coarse. You see, very coarse mesh. Why I use this coarse mesh? With the finer mesh, as I used for the analysis of circular membrane, the program couldn't make any calculation, couldn't make solution. That's why. Ansys is not a suitable program to make membrane analysis. Let's make the solution. These are the solution commands. I explained those before. Again, the same pretension load is applied, while only the shape of the membrane changed. One was circular, one is square, but the edge lengths are same, and uniform distributed load, thickness, all other things are same. By means of those commands, you can understand this by checking the help and command. The video is interrupted. I now continue from the point I was from the place when the video was interrupted. I'm continuing over recording the video. Let's open the program again. I will not open the program again. I explained the codes. Now what I will do is just copying this text into a text file. I did here. I named the text file as square membrane. I open it and pasted these commands in the text file. I did it here and saved them. So what I will do is opening the program, saving, opening the Ansys in the batch mode. Okay, selecting the working directory as square membrane where I saved the text file, and job name can be specified a different name. Input file, and in this working folder I shall point out my text file. File out is the output file name. It can remain as the default name. Run program. Okay. As you see, I have backup database file and result file. Let's check the error file. There is no warning and error, so it's okay. I will change this backup database file extension to DB to use it in Ansys, to open it in Ansys. To visualize the results, I use this interface, this one, run and open the program. After opening the program, you have to click on this button to resume the database. To see the results, first of all, you enter here, results summary. 3 lots are done, each of which has 7 sub-steps, and the total number of iterations performed to obtain the result is 28. The results of the last 28 iteration are required. To get it, I have to make the program read X result. It's the last set, so I click here, okay, and then plot results appear here. Counter plot, nodal solution, degree of freedom solution, Z component of the vertical deflection of the mainframe. Not the true scale, with an increased scale I want to see the result. 10 times I increase the deflection values. Okay, I click on Control and right click on my mouse and to obtain the deflected shape under pressure load. And the value is 0.515 approximately. With hand calculation, it was 0.556, very close to each other. So hand calculation and Ansys solution verify each other. Tensile stress at the midpoint. To see the tensile stress at the midpoint, I have to, you see, I use the coarser mesh. I will explain the reason of that later. I have to select the mid element. For example, stress. You see it's brown, but there are also brown values here. Okay, I can't see it specifically. The maximum value occurs here at the midpoint. As a result, you plot and element select, a new set using graphical technique. This is the element in which midpoint is located. I select this. Say okay. Here I write here plot. I see only this element. So since there is just element is selected and kept in the memory, when I click here and want to see the stress result, I will see the stress results of the midpoint or the element in which includes midpoint. I see that the tensile stress of the element in which midpoint is located at 62,418. And this is average value. Pound square inch. For let's check the non-average values. Keep this number in your mind. Stress X component or Y component, doesn't matter. 62,418. Okay, exactly same value. Non-average or average. Non-average values are element results. Average values are calculated by means of element results. So non-average values are more trustable. So this result is obtained by means of Ansys using a very coarse mesh, and this is the hand calculation, using hand calculation obtained result. Let's see the deviation amount from each other. How much is the Ansys result deviated from the hand calculation result? It's It's almost it's lower than 10%, 9%, 9%. Acceptable, I think, in the safety margin. Even I have used coarse mesh. Why did I use the coarser mesh? Here, a coarser mesh is used than the mesh used for circular membrane. Circular membrane side length is 20 inch. Square membrane side length is 20 inch. They both have thickness, same thickness, 0.0001. They have material properties same. The load applied on them is same, and their supports are fixed. They are subjected to both. They both are subject to the same support conditions. And I use the same pretension load. Using a fine mesh, as I did in the analysis of circular membrane mesh, with the same pretension load, I couldn't get any result. Ansys couldn't make the analysis. I couldn't complete the analysis. No convergence is provided by the program. As a result, either I will find the correct pretension load to be able to obtain the result, or make any other amendment. I, anyway, used a coarser mesh, and with all the things same, all pretension load and everything is same, I obtained a result. That's why I presented this result here. So Ansys software is not suitable for membrane analysis, but for people who are using Ansys, this is the methodology what is done by Ansys, and by means of this video, the users and engineers learn also that health calculations formulas can also be used instead of Ansys. Ansys verified the results of the health calculations by means of numerical examples. I recommend using hand calculation formulas and also Ansys to find stresses and deflections of circular and square membranes. However, finding the pretension load is very hard. I spent hours to find the correct suitable pretension load for this square membrane, but I couldn't do it. Another way is using a coarser mesh, but as you see, the result is conservative, more than the one found by means of hand calculations, but it's acceptable. It's in the 10% deviation from the hand calculation result. We'll put this document to my website. It's this website till the end of next week. Today is 7th May 2023. Till 15 May 2023, I will put this document to my website, this website. You can find it here. There are some other English written books and other documents are given here. Actually, some Turkish and some English. Some of my books are English, some are in Turkish, some are Turkish, some are both in Turkish and English. Please subscribe to my channel to support me. Thank you very much. And